Hi everyone, welcome to our webinar today. This webinar is a presentation of the Northeast Wind Resource Center, and our topic for this webinar is Energizing Cleveland with Offshore Wind, an update on the Icebreaker project. And our host for this webinar is Val Story. Val is a project director for Clean Energy Group, which manages the Northeast Wind Resource Center. And before I pass this over to Val, I'd like to go over a few quick housekeeping notes with everyone. All of our participants for this webinar are in listen-only mode. That means that hopefully you can hear us, but we can't hear you. You have a couple of options to join the audio portion of this webinar. You can either call in using a telephone, or you can connect using your computer mic and speakers. A very important note, we ask that all of our attendees for this webinar please submit your questions as you think of them throughout the webinar by typing them into the question box on your webinar console and hitting send. And we will be reading through your questions as they come in. We're going to save some time at the end of our presentations to address questions from the audience, so please type your questions in as you think of them. Don't wait until the end. Just increases your chance that we'll get to your question. And with that, I will pass this over to our host, Val Story.
Great. Thanks, Sam, and thanks, everyone, for being here. Good morning. This is Val from Clean Energy Group, Clean Energy States Alliance. This morning's webinar is being run through one of our programs called the Northeast Wind Resource Center. The Resource Center is one of 6 wind resource centers that in 2014 was funded in part by the U.S. Department of Energy's Wind Exchange program. Wind Exchange is DOE's program to share information about wind energy and move the conversation about both land-based and offshore wind energy forward in the U.S. Next slide. Thank you. The NWRC, as we call it, serves the Northeast. There are about 6 participating states, both for offshore wind and land-based wind, and we work with 2 project partners, Sustainable Energy Advantage and the Maine Ocean and Wind Industry Initiative, to share information about the offshore wind and land-based wind opportunities in the U.S. In addition, we host a resource library which has peer-reviewed credible studies and analyses on wind issues, and we also host the Offshore Wind Hub, which is a resource of legislative documents, reports, and other information related to offshore wind, and that's all organized by state and at the federal level as well. Next slide. So very excited that today we will be getting a project introduction and a project update on the Icebreaker project, which is being developed by LEEDCo and in partnership with Universal Foundation, and we'll learn more about this partnership and the development today. I will introduce today's speakers before their presentations. First up, we have Dr. Laurie Wagner. He's an experienced energy engineer, and he's been serving as president of the Cleveland-based Lake Erie Energy Development Corporation, otherwise known as LEEDCo, since May of 2010. His previous energy project experience includes nuclear, hydroelectric, solar, and wind. He received his degree from Purdue University and majored in heat transfer technologies for fusion reactors, leading to the development of 2 new non-dimensional numbers. He's developed innovative solutions to industrial sensing challenges, as well as building several land-based wind projects across the U.S. So I hope you'll join me in welcoming Dr. Wagner. I personally am very excited to learn about the Icebreaker project and the extensive stakeholder engagement process they've undertaken and how they've gotten so far in getting PPAs signed and their impressive power pledge in support of the Icebreaker project, plus general facts about the design of the project. So I will let Laurie take it from here. Thank you.
Okay, well, thank you very much for that introduction. Yeah, so, as I started out in nuclear fusion, and that was much too easy, so I decided to go to offshore wind and really pick up a challenge here. But anyway, for those of you who've never been to Cleveland, this is the great city on the lake. This is a picture of when we were in 2013 doing our initial geotech work, and we're about 8 miles out in the lake, and just gives you an idea from a different perspective of where we are as far as the project goes. A couple of side notes. Wind is very near and dear to the heart of Cleveland. Charles Brush invented the first modern wind turbine in Cleveland in 1887. It was about a 15 kilowatt machine, and it was a monster. Lasted for about 20 years, and then fast forward to the 70s. The National Wind Technology Center was actually in NASA Glen in Cleveland, and believe it or not, in the early 80s they had developed the 3 megawatt wind turbine, which held the world record for about 20-some years. And a very strange thing happened in 1982, which is an example of, shall we say, good policy or bad policy. But up until about 1982, wind energy and fracking had been funded pretty much 100% by the federal government. And one of those technologies was given a 22-year permanent tax credit, and the other one was given nothing. So I think we all know what that was. But what's interesting is that fracking has become a technology, good, bad, or indifferent. It is a policy success story, whereas wind migrated to Europe, and we have companies like Universal Foundation and all over. And when you look at the value of the technology in the industry, sorry to say, but the Europeans have owned this, the onshore industry since the early 80s, technology we developed here. So anyway, the goal of LEEDCo and the mission that started about 10 years ago was to bring some of that technology back to the region. And so the whole purpose of LEEDCo was to develop some economic prosperity in the region related to offshore wind. It's going to come eventually, so rather than watch it, we wanted to be a leader in participation. And then, of course, we wanted to generate clean energy locally. It doesn't do the region a whole lot of good to buy RECs from Texas and still have air that is quite contaminated with coal. At one time, a couple of years ago, we were 90% coal generation in Ohio. LEEDCo is kind of an interesting organization. We're a 501c3 nonprofit. We're made up originally of the 4 counties in Ohio along the lake, and then in 2015, Pennsylvania joined it, so we are a Erie County, PA. So we're a multi-state organization. We also have the Cleveland Foundation and Nortec as our private partners. The Cleveland Foundation is the genesis of this idea. They're the world's oldest community foundation. They're also the second largest in the U.S., and to date, over the last 100 years, they've given $2 billion to the community, meaning Cuyahoga County and the city of Cleveland. So, they've been a real leader in education, social services, and now economic development. So this partnership is kind of unique. Unlike the Atlantic or really most of the offshore region around the U.S., the states control the lease area in each state, and there's a different formula, but there's Department of Interior has no authority, therefore BOEM is not part of this equation. So the state of Ohio and the counties in particular are responsible for leasing the area from their boundaries to the Canadian border. So essentially, LEEDCo through its counties controls the lake bottom in the lake. And essentially the counties that you see are the areas within Lake Erie where wind development makes the most sense, both from a resource standpoint. The wind continues to get stronger as you go to the east. So actually our project in Cuyahoga County, which is the second county from the left, has pretty decent wind, but as you go farther east to Lake and Ashtabula and eventually Erie, the wind gets significantly stronger. We're about 8 meters per second, and as you get to Ashtabula, you're about 9 meters per second. Also from an environmental standpoint, the western end of Lake Erie is quite the avian habitat. It's also the fish spawning grounds, and so it really makes sense to think about development farther in the eastern part of the lake. Give you an idea about the support. I'll get into it a little more, but we have spent a great amount of time speaking to people, going out into the neighborhoods, and a good way to describe that is if you think about the lakefront communities, the ones that are listed there, all of their city councils voted 6-0 to support the project. What's kind of interesting is the village of Bracknell is one of the 100 richest communities in the United States. They were actually the first community to support our project, and so quite the different outcome than maybe in other parts of the country. I think it's somewhat the nature of the Ohio character or what's happened to the state over time. Unlike many communities around the U.S., the lakefront was an industrial playground, so to speak. It was a way to use water and build industries along the lake rather than make it totally for the public. So it is quite a unique place in that aspect. In any case, you can see that we also have a good support from some very significant environmental groups and then the organized labor. Another aspect of this is the political aspect. We have bipartisan support throughout Ohio. Those are the the representatives are along the lakefront, and of course the 2 senators. Erie County has been quite supportive since they've joined, and then other members of the state and federal delegation, St. Lawrence Seaway. I would like to point out that one of the most important political or leadership policy positions has been Cleveland's Mayor Frank Jackson. He stepped up in 2011 and said, we are going to buy 25% of the power from this project. This is part of our future. So when you think about the importance of policy, what Mayor Jackson did in 2011 is in large part responsible for us being where we are today. His leadership's been amazing. As we go forward, just to give you another picture of that, we've given over 375 public presentations. Certainly not I have done all of those. We've got a great team. We've done about 200 in the last 3 years, and that's just a listing of the type of groups we talk to. Basically, anybody that wants a presentation, we show up. And we even gave a presentation about 1.5 years ago. We were up on stage with the Sierra Club, the American Bird Conservancy, and us, and it was pretty interesting because you have one group that is very passionate about avian species. You have another group that is very passionate about the environment in general, and then you have another group, namely us, who is passionate about the environment and jobs. So we had a great dialogue. There were certainly some differences, a little bit of meeting of the minds, and we have a plan to go forward working together. But that has been in our DNA since the beginning, is to collaborate and participate and learn a lot from our stakeholders. Give you an idea about the power pledge. This was kind of a fascinating thing. We had a member of our team, Eric Ritter, who basically germinated this idea. So the net of it was we sent people out to 21,000 homes in partnership with the Polling Institute at the University of Akron. And so we polled, through scientific methodology, zip codes, what it would take to make sure that our data was robust and defensible. Of those 21,000 homes, we talked to 15,000. And basically the conversation was something along the lines of, have you heard of Icebreaker? Do you support Icebreaker? 92% of those 15,000 homes said they supported our project. And what was kind of, funny to me, I guess funny in a good way, is that if you look at the lower right corner, you have Mahoning and Trumbull counties, which are some of the most depressed counties in the state, pretty far from the lake, and we received the same kind of support. So it was really very broad. The next question we asked is, why do you support the project? And it was either economic development, jobs, or cleaning the environment. And then we finally said, okay, so if you support the project, would you pay more for the electricity if you were to buy from the project? And 60% said absolutely we would pay more, and we'd pay about $12.72 a month, which give or take works out to 10 to 15% increase in the bill. So that was really a demonstration of market support. We never intended to sell electricity directly, but this has helped us in our path to get our PPAs. I guess we should talk about for those of you who are familiar with the project, this will make sense to you. If you're not, it'll be the first time you see it. But the project has actually been moved about 10 different times over the years for a variety of reasons. The latest was that we moved it a little farther out based on our Geotechnical Campaign, and then also moving out of an area that the Ohio Department of Natural Resources considered sensitive in terms of fisheries. We completed a geotechnical campaign last summer, and the way I like to describe it is in 2013 we went out with a magnifying glass, and in 2015 we went out with a microscope and really looked at very detailed aspects of the soil. We adopted a new foundation, which Christian will talk about. We both have different ways of describing it. I call it quiet and gentle, and he can explain that. We have PPA for 65% of our output, where our PJM interconnection is complete. Fred Olsen Companies, which Christian will talk a little more about, it's actually a group of independent companies owned by a corporation and a family, and they've been in the renewables game since the 90s, and about a 170-year-old company, 160, and very passionate about the environment and the future and doing the right things. And then we commissioned our aquatic species studies with Limnotech, and they will be out next week starting to deploy the sensors and collect the data for the Ohio Department of Natural Resources and U.S. Fish and Wildlife. I guess we should talk about where the project is. So this is a map of the North Coast. As you see, the thin line that goes back to the shore, that's the export cable. And it goes into an old Cleveland Public Power coal plant, which is actually their main substation for the city. So that's about in the heart of the city. If you've ever been to Cleveland, it's the building Weiland came here and painted wailing wall there, which is kind of cool, but that's where we connect. Moving out about 8 miles, we get to the first turbine, and you'll see a string of 6 turbines. There's a 7th location that we collected geotechnical data, more for an option in the event we didn't like what we saw in the first 6. You know, as some of you know, when you get out there, you spend an awful lot of money mobilizing and getting out on the water, and once you get there, you collect as much data as you can. The way Ohio does it is they divide the lake up into 1 minute by 1 minute lease blocks, and so that's shown here for reference, you know, as we started. So for those of you that are interested in the technical details, the turbines are spaced 6 rotor diameters apart in a string that's 323 degrees true north. This is one of our little drones that we had flying, showing you the Geotechnical Campaign from last summer. Give you an idea of what it looks like when you want to do it all at once. As you can see, we went to all 7 sites. The CPT is a cone penetration test, and it's basically a pressure probe that goes into the soil and measures resistance. And then, of course, the boreholes, superficial samples, and we wound up doing 272 lab tests, so pretty robust. And that's data is what we use to design the foundation. And as you can see, like a lot of things we do, we had many partners in here from the state as well as private contractors, and it was a pretty amazing campaign to get this done. It took a little less than 2 weeks, and believe it or not, in those 2 weeks we only were shut down 1 day for weather, which is pretty amazing for Lake Erie. I mentioned the PJM. We went through that process, finished it last July. No system impacts, no system upgrades, and we're good to go with a wholesale market participation agreement. Talked about the PPA. We've been actively working with KeyBank as our partner. They've been vetting our PPA process and, of course, the creditworthiness of the counterparties. The good news for everybody on the webinar and all your friends around the country is we still have 35% available. We have a number of entities that are very interested in purchasing that. So if you want to get your share, call now. The operators will be waiting. At one point, we did have that remaining 35% placed, and then what happened is the counterparty could not do more than a 3-year PPA. Financially, the bank wouldn't support them. So good to know that now. Disappointing, of course, but we're confident we'll have the remaining 35% placed this year. Next. Okay, a little bit about the permitting. I guess you could say we kicked it off April 13th. Really, we had an update with the Ohio Power Siting Board, which is the entity that runs kind of a mini-state NEPA process, much like what the Army Corps does at the federal level. And so it was just a meeting to catch up, let them know we will be moving into the permitting phase this year as the funding comes in. We did start a little bit. What those pictures are is last summer, Limnotech, in partnership with NOAA, the Great Lakes Observing System, and us, deployed 2 buoys, as you can see in the picture, and one was the one closest to Cleveland is at our project site, and the other one was about 12 miles out. And they were looking at dissolved oxygen, water quality, and so it was a kind of like a pre-test for us in terms of collecting data. Most of that data was for City of Cleveland, water quality, and NOAA. but it was a way to develop a good relationship with Limnotech, who is one of the premier agencies or companies that can collect aquatic data in various forms. They service the buoys, they find people to analyze the data, so it was a really good experience. So that will be deployed next week. We'll continue in the permitting process in Ohio. It says here we kicked off with the Army Corps in April. Actually, it's going to be in a couple of weeks. We've had a few discussions just trying to keep the Army Corps up to speed what we're doing in Ohio, and then we'll follow through with that for the rest of the year. What do we have? Okay, so one of the things about LEEDCo that is quite different than any other developer in the U.S. is that rather than having all of our development assets within the company, we're a very small group. One time we had as many as 5 people, and so our method was to go and partner with the people who either locally know how to get this done or have the experience in the world to get it done. And so from an installation standpoint, again, it's probably as similar to one of Christian's slides, but we partner with Frederik Olsen Windcarrier. They are the leading offshore wind turbine installation company, and believe it or not, they have taken a process that in some cases has taken up to 2 or 3 weeks to put up a wind turbine, and they've put one up in 11 hours. So they don't all go that well, but that's the kind of experience we need here. And as a point of interest, the Block Island wind farm is also going to be using Fred Olsen, but they were our best friends first. But in any case, we wanted to partner with people who really know how to get this done and have been out on the water. The next thing is talk a little bit about the foundation, and then I'll turn it over to Christian. We're using what's called the mono bucket, and it's basically a large can on the bottom with a monopile on top. And the can is, when you put it, you take this foundation, you set it on the seabed, you evacuate the water, and it sucks itself down into the soil. And then it basically captures that amount of soil and uses that as the mechanism for providing the support. And in our particular case, it's actually capturing about 3,000 tons of soil. So once it's in place, it acts like a gravity foundation. So it's a pretty interesting product. We spent a long time evaluating this. We actually looked at every foundation type out there. We looked at a jacket. We looked at a gravity base, a monopile, a circular cell, which is sheet piling filled with concrete, and eventually, over the last several years, we've decided that this by far is the best solution for us, and also other places. Christian will have a nice little video, but this, as you can see during installation, it's very fish-friendly. And to me, what's amazing is as it's sinking into the ground, there's no seabed disturbance. So I think that from a environmental point of view, that's a very nice benefit from this this foundation. And just to finish up here, we also did a study under the Department of Energy where we looked at the mono bucket, and we compared that to the monopile in the jacket for the East Coast. And essentially, if you look at the areas, there's kind of 2 areas in the sense of wind regime as well as water depth. And so the Virginia, Maryland, New Jersey area is give or take around 25 meters, and then the Rhode Island, Massachusetts area can be on the order of 50 meters. So the net of this is that in almost all cases, the mono bucket is the lowest cost foundation, in some cases very significantly, compared to the alternatives. When you get into pretty shallow water with a smaller turbine, it really depends on the exact soil conditions. It's pretty comparable to a monopile, but it gives you an idea what's going on. We also did a survey of all the right whales up there. They all put their fins up and says monobucket is the way to go, no noise, so we were really pleased with that. And that is it. This is a photo sim of what the wind turbines would look like off of Cleveland. And as you can see, once you're 8 to 10 miles out, it takes a pretty clear day to see anything. And Cleveland being the sailing city it is, most people will think it's just another day out on the lake with sailboats. So that's it for me, and happy to turn it over to Christian.
Great. Thank you so much, Dr. Wagner. We will move on to Christian's presentation next. Just a reminder to please enter any questions you may have into the questions dialog box, either for Dr. Wagner or for our next speaker. So Christian Jacobsen is Head of Business Development at Universal Foundation. He's been there since 2013. Universal Foundation is the company behind the Monobucket Foundation, which you have just been introduced to. It was first deployed in 2001 and has been used at several offshore wind farms in the UK and in Denmark. The Monobucket is the foundation that's been selected to support the 6 turbines in Lake Erie. As a background for Christian, he has a background as a management consultant for offshore wind with a specialty focus on merger and acquisition activities, including involvement in some of the major bankruptcy situations in the European offshore foundation supply chain. This provides Christian with a unique insight into the pricing mechanisms and levels across the foundation market, as well as a broad network within the industry. He holds an MSc in Marketing and Strategy from the Aarhus School of Business in Denmark. And with that, we will move on to Christian's presentation. Thank you.
Thank you very much, and it's a pleasure to attend this webinar. I'm currently located in Copenhagen in Denmark, and really pleased to be joining this webinar today. So I'll give you a quick rundown of the background for Fred Olsen being part of the project, and then move into an introduction to some of the work that we have done with LEEDCo, most predominantly the comprehensive due diligence process that we ran over almost a year together with Laurie and his team to basically convince Laurie that the foundation was the right choice for the projects. So we did spend quite a lot of time on it and ultimately ended up on top. Yeah. So Fred Olsen in offshore wind or in renewable energy, it's basically 1,500 employees in renewable energy. The upper left corner is our onshore renewable development department with a capacity of almost 500 megawatts installed in Europe. We have Fred Olsen Windcarrier, as Laurie just touched upon, with 2 massive jack-up vessels, and they are mostly suitable or dedicated to turbine installation, so offshore wind turbines. We also control service boats, and with these service boats we take our operations and maintenance teams offshore, and that is done in the company Global Wind Service. One of our distant cousins, that is Harland and Wolff, the company who actually built the Titanic, and as they say, it was fine when it left the yard, and Mr. Fred Olsen also controls that yard, so we have the luxury of being able to manufacture our own foundations in Europe actually. Mr. Fred Olsen himself is a man of 87 years old. He's an entrepreneur by heart. When he steps into something, he wants to make a difference. And when he's decided to step into offshore wind, it was to make a difference in terms of reducing levelized cost of energy. So he has been dedicated to that ever since. Laurie, you said that we actually installed turbines now in around 11 hours. The first project that these jack-up vessels participated in, they started with a cycle time. So that means from arriving at the site to having installed the turbine, it took them around 24 hours. When they left the last location, that was installed in a record-breaking 8 hours only. So again, a testimony to making a difference when Fred Olsen steps into an industry. That is also the case for the U.S. market, where Mr. Fred Olsen and the company have long-standing relations, and basically saw that the Lake project was the perfect project as one of the first to develop an industry in the U.S. I see it as being a little bit neglected. There's a lot of activity on the East Coast, but the Lake project is the perfect location to develop low-risk offshore wind and clean energy in the U.S. Our foundation, the monobucket, basically builds on a suction bucket technology. Not many suction buckets have been installed in offshore wind in Europe, but in oil and gas, more than 2,000 suction buckets have been installed worldwide. One of the largest manned structures or manned-built structures in the world, the Troll A platform, is actually supported by suction buckets. And that was built and deployed out of Norway. So the experience is there, and that is what we are trying to capture and transfer into offshore wind. So how does it work? As Laurie also said, it works like a tin can, where you basically evacuate air or water from inside the foundation. We attach a bespoke piece of equipment called a suction pump unit to the top of the structure. We lower the foundation to the seabed. Dead weight and gravity ensures that we self-penetrate to close the cavity of the tin can. The pump unit enables that we build under pressure, and then we work with the water pulse along this skirt tip of the foundation to basically liquefy the seabed. The combination of the two ensures that we are able to penetrate into the soil and capture the 3,000 tons of soil, as Laurie also mentions. We have a number of quite unique tools that enables us to control verticality, so we ensure that the turbine, which is ultimately put on top, is perfectly aligned and ready to produce power. Then we remove the suction pump unit, deploy that for the next site, and do it all over again on the second, third, and fourth foundation. The track record in our company, as Val said, it's a timeline stretching back to around the millennium, where the first project was deployed with a 3 megawatt Vestas turbine in Frederikshavn. We have done a MetMast project at a site in Denmark, also Horns Reef. The unique part of that project was basically a floating installation concept. Dogger Bank in 2013, which was the first project seeing Fred Olsen's involvement in the company. And that was the deployment of 2 MetMasts offshore at the most harsh working environment in the North Sea. We were so lucky that the first winter we were hit by the 50-year design wave, and that was a monster of 20 meters. That is equivalent in feet, around 65-meter wave that hit the foundation on a site where we only have 25 meters of water. So that was a monster. Then in 2014 we completed a trial installation at 3 major sites in Europe, and that was basically a program set up to de-risk the foundation, and also this has benefited the Lake Erie project in terms of demonstrating that we are able to basically push the envelope much further as we originally believed was possible. And then we are proud to be part of the Icebreaker project and hope to see that as being one of the first major offshore wind farms in the US. I have included some pictures. This is a picture from our Frederikshavn project with the Vestas V90 3 megawatt turbine. It was a foundation of 135 tons, a bucket of 12 meters in diameter and a height of 6 meters, and that is still in operation. The turbine on top, the V90, is a prototype turbine from Vestas, which basically means it's one of the most tested turbines in the industry, which has also meant a lot of monitoring on the effect on the foundation. We are proud to see that still being in operation. The metmast for the Danish project Horns Reef 2 was deployed in 2009. It was the first metmast with a monobucket on top or below, and it has been one of the world's largest wind farms in Denmark. And the unique part here is that the foundation was floated out, so instead of having to rely on a very large vessel, we actually only used a slightly or a small crane to upend the foundation and then do the final installation. Another unique feature of this project is that we were able to fully decommission the foundation. And how that basically works is that you reverse the process. So instead of sucking into the can, then you put pressure in, and then the foundation comes out. It means that we are able to 100% remove the foundation after being in effect with the turbine, having been deployed at a project site for 20-25 years, leaving the seabed completely as it was when we deployed the foundation. And that is one of the major benefits of suction buckets in general, that you are able to remove the foundation. Then we come to the first project, seeing the Frederik Olsen involvement. And here I would like to show a video, just briefly outline that the foundation here is 350 tons. It's 15 meters in diameter and 7.5 meters in height. And I'm trying to see if I can just bring up the video here. We do have a little bit lag on the video, but this is basically from the manufacturing hall at Harland and Wolff in Northern Ireland. Where the foundation was manufactured, prepared for loadout, and again, this is the same yard that did the Titanic. We did this with greater success because the foundations are still standing. As you can see, it's some quite big structures within the manufacturing hall here. The lower part is attached to a lid, and on top of that, a shaft is mounted. We use the SPMT, so self-propelled motor vehicles, to transport the foundations out to the quayside, where the Fred Olsen turn vessel was waiting for pickup and loadout. And a beautiful day in Belfast, as we see here. So this is the lower part, this is the suction part of the foundation. And here we see pictures or the video showing the shaft section of the foundation, which was then attached afterwards to the main structure. This was done by using one of the big gantry cranes at the Harland and Wolff. And then shortly you will see that we have a vessel lying next to the foundation. Here we go, the orange vessel, and that is the brake turn where we loaded the two structures on board and then set out on a beautiful day. This is a snapshot of how the installation actually worked. It was taken off the vessel, lowered into the seabed, and then after 7 hours the foundation was completely installed with a topside being a met mast. That has been providing valuable data to the client in terms of the wind resource, and the client will optimize his project based on the measurements provided by this foundation. And here we see the flounders. That was what Laurie was talking about. We normally joke either the flounders are very happy for the foundation, or then they are looking for their friends inside the cavity of the structure. But regardless, it's noise-free, and as you'll see in a second, that brings some added benefits to except just being fish-friendly. And now I might have to, yeah, there we go. A beautiful picture from the North Sea with the loadout. Here we have the flounders being undisturbed during installation. And this is pictures from our trial installation. The result was that we ensured 29 installation in record-breaking 24 days. That has resulted in a very unique soil database. Then we met the nice guys from LEEDCo, and I am proud to have been part of the process to secure the first commercial project for Universal Foundation, and I am excited to see that project go online in a couple of years. So why the lakes? Basically, if you look at the lakes across the states, then Lake Erie is shallow water. It has a massive wind resource. We have an ambitious target of 5 gigawatt offshore wind deployment in the area. High public support is a valuable asset for any project, and then we actually have a local supply chain which is available and ready to support the process as well. Again, it is a perfect site to deploy wind in general. So why did we focus on the foundation, or why did the team behind LEEDCo focus on the foundation? Based on this split, the foundation basically contributes to or amounts to 20% of the total cost of levelized energy or levelized cost of energy. The turbine is around 1/3 of the levelized cost of energy, so it is massive. The contribution coming from the foundation. If we compare to the conventional and preferred monopile type foundation, as we see deployed quite a lot in Europe, then our structure has the benefit of having one lift, one vessel, and then we use this suction pump unit. The comparable monopile relies on a number of complicated and expensive pieces of equipment to ensure installation. In total, that translates to cost saving. And here we have just indicated a cost saving in the area of 30%. And that has been confirmed in the projects we have been participating in. This is a picture taken from a monopile project. You come out with noise mitigation shields, you come out with big hammers, and you come out with vibrators, you come out with upending tools, flange correction tools. There's a lot of equipment on these big vessels. The vessel that you see here has a day rate of around $300,000 US. So it is expensive equipment that you come out with. The deck on such a vessel is quite packed for monopile installation. You need to go out and scour, protect the foundation afterwards. That's another vessel that goes out to secure that. And then during installation, you have the noise problem. the problem is particularly big in Germany, and we also see that increasing in the States, being a problem. For the European utility client Vattenfall, one of their projects saw deployment of a number of noise mitigation systems. First they deployed what is called a big bubble curtain, then they deployed a double big bubble curtain, then they deployed a double big bubble curtain with a linear bubble curtain, then upped that with a triple big bubble curtain with a linear bubble curtain. It is a massive operation, and in total this translated into a cost for the project of 20 million euro, and that the equivalent in US dollars is around 23 million US dollars. That is 290,000 US dollars per foundation. So it is really expensive. The reason they are, at least in my view, showing this number is because they are probably the best in the industry. Other projects have seen much higher numbers to mitigate the problem of noise. So when we go offshore, we bring a click-on unit, we bring a transportation frame, we need to lift the foundation with the lifting yoke, we have a control room where we ensure the installation from, and then we bring some water to stay dehydrated, or hydrated, sorry. And in total that brings a much more simple installation setup compared to other foundation types. Again, it translates into cost saving. Yeah, and here we have a picture from offshore at Dogger Bank. Nice pictures, 2 foundations standing ready for deployment with our brave turn vessel. The final slide is basically a summary of all the benefits. I think I'll leave it up to Val for the questioning now, but please look into the benefits. It all translates into reducing levelized cost of energy, and that is the reason for us being part of this industry. We need to bring the cost down to make offshore wind fully competitive with other energy types. And finally, the offshore inhabitants, they are already convinced that it's a good solution. Luckily, we were also able to convince Laurie.
Great, terrific presentations. Thanks to you both. I'm going to quickly jump into the questions. We've gotten quite a few coming in. Feel free to keep submitting some, and I will try to get to as many of them as possible. So let me work backwards and start with some questions on about the foundation. Is the infrastructure in place to build and install the foundations for the Icebreaker project?
Yeah, the answer is yes. Just to give you an idea, we recently went out to bid for the primary steel, and there were 5 manufacturers in the Great Lakes and 3 from the Gulf who are bidding on it, and the numbers, we have 6 out of 8 that are in, and the numbers are very competitive, and so that includes the manufacturer and the transportation to site.
Great, and as a follow-up to that, if this project is successful, is there any chance that manufacturing could take place in Northeast Ohio, for example, for the foundations or turbines?
Yeah, certainly on the foundations, one of the bidders was from Cleveland, and our goal is to bring as much of that as we can to the region. As far as the turbines go, I think it's the same old story anywhere in the world. Until you get an industry, until you have enough turbines being deployed, you're just not going to see much manufacturing. Although we are hopeful that the towers for the turbines can be made in the Great Lakes region as well.
Great, that's encouraging. Christian, could you repeat how much the foundation weighs?
Yeah, currently we are looking at a foundation weighing, I believe it's around 350 tons for the lake projects. And just to put that into perspective, we expect a turbine in the range of 3 to 4 megawatt. If we then look at some of the European projects we are engaged in, we are looking at turbines of up to 8 megawatt and foundations weighing around 1,000 tons. So in the lakes it's a light foundation, but it's also a comparably smaller turbine.
Which brings up the next question. What is the size of the turbine that will be installed for this project, and has a turbine supplier been chosen?
Well, the turbine was picked much like you would for any project based on the wind resource. And we have an IEC Class 2 wind resource, and there are only 2 manufacturers that are really bankable in that region. And so that's Siemens and Vestas. The size of our turbine is a 3.45 megawatt. And what you'll see from both manufacturers is they both have a 3 megawatt platform that has evolved to 3.3, 3.45, 3.6. You know, that's all I'm going to say about the manufacturer.
Okay. The project is called Icebreaker. What is the impact of ice on this project?
Well, that that always comes up. Ice is simply another load on the foundation. To give you an example, if you compare our turbine with a turbine in the North Sea with the same winds, you have the loads from the wind. The difference is in the North Sea you will have significant wave loading, which is on the order, or can be on the order of the wind loading, whereas in the Great Lakes the waves are pretty insignificant in terms of loading, whereas the ice becomes a larger load. So the ice is a contributor for what's called the ultimate limit state, which is the maximum load you can have on the foundation, and it's about a little less than 1/2 of the wind loading. And then on the fatigue loading, which is, during the operational lifetime, the wind is the governing load and the waves don't contribute much. Whereas in the North Sea, the waves also contribute to the fatigue loading. So long story to say that it's simply another load on the foundation. But the way we approach this is that we brought in the world's ice expert from Finland, who put up a turbine in 2009 in heavy icing conditions every year that are greater than what has ever been seen in the Great Lakes, or I should say Lake Erie. And they're now building another project with 10 turbines, and we're very very conservative on our design, much like they were with the first turbine. And just by comparison, the turbine that went up in 2009 compared to the one that's being put in now, the current ones are about 50% less steel. So we're using the same approach, start very conservatively, and then take measurements during the process, and then and ice loading has been used, bridges, Arctic, so all of our ice team, both Aranti Engineering from Finland and DNV Arctic Ice Team, have a lot of experience, as well as the U.S. Army Corps' Cold Regions Research Laboratory. Just recently finished a study for us. They collected all of the ice data that is known for Lake Erie, as well as satellite data, to determine the worst case conditions, and we actually designed for 2 to 3 times worse conditions than we've ever seen here.
Great, thank you. I know we've exceeded the hour, we have lots more questions here. I know we won't have time to get through all of them, but if you have time, I could run through a few more. We've got questions about project installation and project timeline.
Yep.
And for those who have to go, we are recording this webinar, and it will be available on our website, so you can always check back in. So a little more on installation. What vessels will be used for the installation, and how will these be transported to the Great Lakes?
The current plan is to use what's called a vessel of opportunity. Basically, a U.S. vessel, the foundations can be installed from a crane barge. So we really don't need the type of jack-up vessels. Christian and Universal Foundation, we're fortunate that they have two of the best in the business. But once again, in Lake Erie, we can use a floating barge or a spud barge with a crawler crane, and then put the foundations in. And that's one of the real benefits of having Windcarrier, our partner, is that they do all the load and stability analyses, and make sure that technically it can be done, and then of course it can be done safely. The only downside to that, if there is one, is that we will be more susceptible to weather, but again, the average wave height in Lake Erie is a ½ meter, and usually you're limited by a 1 meter to 1.5 meter when you can't install. So we might, instead of getting the foundation, each one in a day, maybe it'll take us a week to get it in. But the difference is, instead of paying $300,000 a day for the vessel, we'll be paying.
Oh, I don't know if it's just me, but
oh, there
we go.
40,000 a day. So it comes down to a compromise. Yeah, I'm here.
Yeah.
Great, we can hear you now. You had dropped off.
Okay. You hear me?
Yes.
Yeah. But it is an interesting challenge. And as you say, Laurie, in the lakes, we are so fortunate that we don't have the big waves. So again, in some of the European projects, we have to basically cope with waves of up to 70 feet. Quite significant waves, and definitely not something you want to be operating in and installing in. That puts a limitation on how much of the year you can actually install foundations and turbines in the industry. And normally we say that half the time is spent just waiting for the weather to clear up. And in the lake, I would say the limiting factor is the ice moving in at some point. That gives you a natural limitation. But small waves and quite good conditions to actually go out and install both foundations and turbines in.
So what are the cost implications of developing an offshore wind project in the lakes versus the ocean? You've talked about you can use U.S. vessels, the weather isn't as harsh. Does this equate to lower cost of energy?
Maybe I can start and then you follow up, Laurie. Normally, when you go far offshore, then you have a better wind resource, and that has a significant impact on your overall business case. But going far offshore, it also means having to cope with a very long cable going onshore. It means complicated offshore marine spreads, expensive vessels, more expensive foundations, and then you tend to basically optimize your project by putting a bigger turbine on top, simply to spread your capex cost over more megawatt put in a simple way. In the lake, you have a limitation that you can't bring in big vessels. So if you look into the future, I would essentially see that smaller turbines are perfect for the lake. Again, it's 25 meters of water instead of being 45 meters and up to 50 meters in some projects that we see at least in Europe. So it's different economics. The wind resource is quite strong in Lake Erie. It's not as strong as if you go far offshore, but it's equally strong as being near shore. So for us, the economics work out quite well in the lakes compared to when you go out into more challenging offshore conditions.
Okay, thank you for that. Moving on to the project timeline. What are the next steps in the timeline for moving from permitting to installation? Are there other studies that are needed? You mentioned that permitting, I think you're taking on permitting this year. What's your outlook? I think perhaps we've lost audio there.
Laurie's back. My computer crashed. So.
Well, then I can maybe respond to the question. Of course, from our side, we are quite focused in Universal Foundation to complete the foundation design and work closely with the number of fabricators that we have identified together with LEEDCo to go out and make the business case solid enough to complete a final investment decision. Then on the other hand, we have our good colleagues in the Windcarrier. They are of course taking our design and look at how the installation setup ultimately will look like, what type of vessel will be used, and they already have some very good ideas and done quite a comprehensive work on that side as well. So we have a very, very good idea of how the business case will look like. We just need to make it solid, 100% watertight for the investor also to build a good business case around the project. And then maybe Laurie, you can respond to when do you expect to see turbines run on the site?
It appears that we have lost him again.
His computer maybe crashed. Well, then I can maybe answer. From our side, we would like to develop the project as quickly as possible, but we also respect that things take time. So I would say if we can get the final investment decision in place this year and then have a fully developed project by 2018, then I would, on behalf of Universal Foundation, be quite pleased.
Great, thanks. And I don't know if you can answer this question, but I understand that the Icebreaker project was one of the initial recipients of DOE's Advanced Technology Demonstration Project funding. Do you know to what extent DOE is supporting the Icebreaker project and LEEDCo currently?
Yes, LEEDCo received a grant of, I believe it was 3.7 million last year, and still using that grant. Naturally, there's the ongoing discussion of some of the bigger grants. I believe it's up to $40 million US, which have been allocated to other projects in the US on the East Coast primarily or only. And on some of those projects, there is still the question mark: will they go ahead? Hi, Laurie.
Yeah.
Laurie, maybe you can respond to the question of Department of Energy grants and how the project is supported by that.
Say that again. My computer crashed again, so I just went on somebody else's computer. What was the question?
How Department of Energy funds the project and supports the project going forward and
Yeah, so the Department of Energy, initially they funded 7 projects in 2012, and then they had a down select and picked 3 projects, and Maine and LEEDCo were put in an alternate status. So the 3 projects that DOE picked were Fisherman's, Dominion, and Principal Power out in Oregon. And so what they have done is those projects, the 3 projects that were picked are currently working, but they're in a holding pattern in terms of funding. They're currently on a contract extensions with no funding, and they are taking Maine and us up to the level of funding of those 3 projects. And this month, all of the projects are making the case to the Department of Energy for going forward. And so, we're currently in a contract to go forward for the next year, and then the Department of Energy needs to make a decision. Do they keep the 3 projects that they picked, or do they drop any of them and then bring in either us or Maine or both of us? So as for today goes, we're supported by a contract from DOE, and then it remains to be seen if we're brought into the demo program as one of the prime projects.
Great, thank you. I think we will end it here. We've run over the hour quite a bit and have made it through the major categories of questions. Just as a reminder, we have recorded the webinar. It will be posted on our website, and you can see the website address on your screen now. My email address is also up there. It's val@cleanegroup.org. Feel free to send me any questions if you might have any. And finally, many thanks to both you, Laurie, and you, Christian, for 2 very exciting and informative presentations. I've learned a lot today and wish you the best of luck moving forward with the project. Thanks, everyone.
Okay, thank you very much. And anybody on the webinar that would like more information, feel free to contact us, and we'll be happy to talk to you about whatever you want.
Perfect. Thanks. Yes, feel free to. I'm not sure if we had your email address up there, Laurie, but folks can run questions through me, and we can get them over to you.
Okay, sounds good.